Hi guys, today we're going to talk about finding the area of irregular figures. So these are going to be some weirdo figures that we're going to be talking about. So first let's remember how to find the area of a trapezoid because it actually was kind of our first irregular figure. There is a formula for area of a trapezoid, but we'll talk about that in a few weeks. But what we did is we cut it up. We cut it up into a rectangle and two triangles that were the same. So this was 1 by 4. So this rectangle was 4 meters squared. And since this piece is 1, this piece is 1, and that leaves us with 4 more for each of these pieces to share. So this would get a 2, and this would get a 2, and that's what the base is. The bases are 2. The height of the triangle is 4, and that formula is base times height divided by 2. Or 2 times 4 divided by 2, which is 8 divided by 2, which is just 4. So that's 4. This is 4, and this one is the same, and that's 4. Add them all together, and we get 12 meters squared for that area of the trapezoid. So what are irregular figures? They're just kind of strange figures that can be put together with parallelograms, rectangles, and triangles. And there are a lot of different ways you can cut these figures up and use the things that you know to find the area. So for example, some kids will see this and they will cut it right here. And they'll say, here's a rectangle, I can find the area that way. Some people will say, no, I'd rather cut it right here. Here's a rectangle, I'd like to find it that way. And then there's some kids who see the whole big rectangle and they'll find the area of the whole big rectangle and then they'll cut out that little piece of small rectangle. And that's still another way you can do these problems. So if you do these problems a little different than me or your friends, that's quite all right as long as we get the same answer. So first, let's look at this kind of house looking figure. What would be the best way for us to cut it out so that we can use our area formulas that we know? Well, this is a triangle and that's a weird shape. So we don't know how to find the area of that weird shape, so this would not help us. Here's a rectangle and here's a triangle. I like the way this looks. Here's a triangle, and this is kind of a strange thing. This is actually 2 trapezoids, which is not bad, but then you would have to cut it again. So that would be 2 cuts. So I think our best bet would be the second figure cutting. So we're going to find the area, this time by cutting it in the way that they showed. So you're going to use the area of the rectangle, which is base times height. So for this rectangle, it'll be 8 times 4, which is 32 meters squared. Then this piece would be 5 times 6, which is 30 meters squared. And we can add them together. 32 plus 30, that's 62 meters squared for the area of this entire piece. Now, like I said, there's other ways you could cut it as well. And I don't know if they're going to do that on the next slide or not. Let me see. Nope. So I'm just going to show you. If you would have cut it here, you have this big rectangle that would be 10 by 5, which is 50. And then you have this piece, which is 4 by something. Now, it's kind of hard to figure out what this little height is, but this much is 5. So this much is 5. And the whole side is 8. So that's 4 times 3, which is 12. And once again, you get 50 plus 12, which is 62, which is what we got the other way. The last way you could do it is you could make a gigantic rectangle, which would be 8 times 10, and that's 80, but that's too much. We're going to cut out this little piece, which is 6 by some distance, I don't know. But remember what we just talked about. If this is 5 and this is 5, that would make this 3. So this would be 6 by 3, and this rectangle we're cutting out is 18. And 80 minus 18 is also 62. So there are 3 ways we could actually solve this problem. So again, if you do things a little differently, that's okay. So take a second, pause it, and do this one the way you choose. I'm going to go ahead and cut it right here to start. That will be 3 times 7, which is 21 for this piece. And 4 times, I don't know what this piece is. I know the bottom is 3, so the top is 3. That leaves the whole side is 8. Cut out that 3, and that leaves me with a 5 here. 4 times 5 is 20. And I have 20 plus 21, which is 42 meters squared. Let's try this irregular figure. So it kind of looks like a house. And you have the base of this triangle will be the same as the bottom of the rectangle, which is 8 inches. The area of the triangle would be base times height divided by 2, or 8 times 6 divided by 2, which is 48 divided by 2, or 24 square inches. The area of this rectangle is base times height, which is 32. So you would add them together to get the irregular figure, which is 56 square inches. Here's a real world problem talking about a strange room here. This room, they want carpet in it, and it's $4 a square foot. How much will it cost to carpet the room? So we got to figure out how many square feet are in here. So we can break this into a parallelogram and a rectangle. So what do we have here? The whole height is 13. This much is 6. So then this much will be 7. So the rectangle is actually 15 by 7. Base times height, you would take 15 times 7, which is 105. So this piece is 105. Then you'll do base times height of this guy. You're looking for the right angle. The base is 15. What about the height? Well, the height of that piece is 6. 15 times 6 is 90. So I have 105 and I have 90. So I'll take 105 plus 90. That's 195 square feet. It costs $4 a square foot. So how much will it cost? I'm going to have to take the 195 times 4 to get 780 square feet. Oh, lying, $780 to carpet the room because it's $4 a square foot. Let's look at this one. This is a playground, and they're going to put some rubber mulch on it. So which way will show us how to do the area? And we don't have to do it this way because there's lots of different ways to do it, but let's see if we can figure it out. Definitely we're going to take 40 times 25 somewhere because that's going to give us the rectangle. So these guys are out because they don't have 40 times 25. This one has it dividing by 2, but that's what you do for triangles. So we know it's going to be one of these two. Now we just need to figure out how to find the area of this triangle. It's base times height divided by 2. This is the height, it's 20. So the base of the triangle will come from taking 40, subtracting the 18, and that will give us 22 for the base of the triangle. 22 times 20 divided by 2. This is the area of that playground. So we can figure out what that is. One rectangular section was 40 times 25. That is 1,000. The triangle section was 22 times 20 divided by 2. So 22 times 20 divided by 2 is 220. And that gives us a whole area of 1220. They're going to put some mulch on it, and it only covers 122 square feet. So how many tons will they need? Well, I'm going to take the 1220. I'm going to divide it by 122. And that gives me 10 tons of mulch that I should buy. That's it on the irregular figures.